Okay, so for our graphs, we need our title, which is going to be our x versus our y. In this case, we're really not entirely sure which one is the independent variable and the dependent variable, except for that they've told us. It says to use frequency as the dependent variable and wavelength as the independent variable. So the independent variable, it goes on the x-axis. So we're going to put wavelength in nanometers down here. And then we're going to put frequency in hertz over here. And then for the title, we want dependent versus independent. So your y-axis versus your x. So this is a graph of frequency versus wavelength. Okay, so the tricky part about this is plotting your points. We want our graph to take up the whole space. Okay? We don't want to use this giant graph paper and have our graph be this big. That's a no. So what you're going to do is you're going to take your largest data point minus your smallest data point and divide that by the number of boxes. So let's count our boxes. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. We have 36 total boxes. All right, and then for wavelength, our smallest value is 3, our largest is 9. So we're going to do 9 minus 3 divided by 36. So 9 minus 3 divided by 36. That's 0.166666. We're going to call it 0.17. I'm going to multiply that by 2 because I'm going to skip every other box. So I'm going to have 0.34 as my add. So I'm going to start my wavelength at my lowest value. So instead of this being 0, 0, this is going to be 3 because that's my lowest wavelength value. Then what I'm going to do is I'm going to add, so I'm going to start with 3, and then I'm going to add 0.34 each time. So every other box, so this is 3.34 plus 0.34. So this is 3.68, excuse me, plus 0.34. So this is 4.02 plus 0.34. You're going to do that all the way across until you run out of boxes. You should be pretty close to 9. It'll be a little off from 9 because we rounded, but not too bad. Alright, so mine ended out right at the end at 9.12. That's kind of perfect because it goes from 3 to 9, and that's what we want. We're going to do the exact same thing with frequency. So we're going to count our boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Perfect square. Alright, now this time though, our lowest value is 3.3. Our highest is 10. So we're going to do 10 minus 3.3 divided by 36 boxes. That's 0.186. We're going to multiply that by 2. That's going to get us 0.37. So our number that we're going to add is 0.37. Okay, so we're going to start at the very bottom where you would normally have 0.0. This is going to be 3.3. That's our lowest frequency value. Then in our calculator, we're going to put in a 3.3, and we're going to add 0.37. We're going to skip one, so this is 3.67 plus 3.37, 4.04. We're going to do this all the way up to the top. So that's kind of perfect. We ended at 9.96, which is a little high, which makes sense because we rounded up considerably. That's all right. So our next step was to plot our points. Remember, we want to use either a dot with a circle around it or an X, so when we draw our best fit curve, we can still see it. So our first point is at a wavelength of 9 and a frequency of 3. So our frequency of 3 is all the way down here, and then this is going to be right here. So I'm going to put my dot, and I'm going to put a circle around it. I like to mark them off as I plot them so I don't get lost as to where I am. So a wavelength of 7.5, frequency of 4. So I'm going to go to my frequency of 4, which is right here. And then my wavelength was 7.5, which is going to be just past this line here. So I'm going to slide that out, put my dot, and a circle around it. All right, and I'm going to cross off that point. Then I have a wavelength of 6.25 and a frequency of 4.8. So the frequency of 4.8 is going to be right about there. I'm actually going to use this little piece of paper to help me here. So frequency of 4.8, and then a wavelength of 6.25, which is going to be kind of right in the middle of this. So this is going to be right about there. Okay, crossing that one off. Then I have 5.75 and 5.2. So my wavelength of 5.2 is going to be, or excuse me, my frequency of 5.2 is going to be right about here. And then 5.75 for my wavelength is going to be right over here. So I'm going to plot that right there. Put my circle around it. So now we have 5.25 and 5.7. So I'm going to start with a frequency of 5.7, which is going to be right in the middle of these two. And then 5.25 is going to be right about here. Now, this isn't going to be perfect because we're kind of estimating our graph. That's okay. Wavelength of 4.5, frequency of 6.7. So starting with my frequency of 6.7, it's going to be right here-ish. A little bit higher than that. And then 4.5, it's It's going to be right about there. Then I have 4.0 and 7.5. So 7.5 is going to be right about here. And then 4.0, follow that one straight up, right there. And our very last point, 3.0 and 10, it's going to be right on our y-axis, just a little bit above where we're at. Boom. Now, this is very obviously not a straight line. This is a curve. So to do my best fit curve, what I'm going to do is I'm actually going to rotate my paper so that my elbow bend kind of matches. And what I'm going to do is I'm going to take several practice swipes with my pen before I put it down. That way when I put it down, I'm going to go through most of the points. Does it have to perfectly go through every point? Absolutely not. That's okay. That's okay. So if we're looking at the notes that we just did at the beginning of class, this is an inverse relationship, this curve. So when the wavelength goes up, the frequency is going to go down. That is indicative of an inverse relationship. So on the back, you have some calculations to do. You're going to compare multiplying wavelength and frequency and dividing them. One of them is going to get you the same number every time. The other one is going to get you something different every time. The one that gets you the same thing every time is going to be our equation. Okay? So you're going to use your graph to answer all of these questions. And then we have another graph. This one is energy versus frequency. You'll notice that this is the other graph. This is the direct relationship. So when frequency goes up, the energy goes up. When frequency goes down, the energy goes down. So this is a direct relationship. So you're going to answer these questions using this graph as well. Okay?